So it's about management and recycling of waste rechargeable batteries. And for those who of you who don't know me, let me see, there should be, ah, that's me at a factory inspection, a battery recycling factory inspection. Actually, I come from the German Eco Institute. We are a non-profit research institute, so we don't do recycling ourselves. Nevertheless, we have a lot of field work in recycling fields, and I myself particularly in battery recycling. So I hope to cover that gap of not being a recycler with some field experience. Um, to just give you a short overview about what I prepared, first the main types of rechargeable batteries, and then go into more details into lead-acid batteries, then lithium ion and nickel metal hydride batteries, their characteristics, the do's and don'ts for the recyclers, how to manage them, and where to sell them or where to ship them. A short summary, and then if there is still time and still demand, the fifth chapter, a quick check to shortlist recycling partners for lead-acid batteries. I think for lithium ion it's quite straightforward. For lead-acid batteries, there are many around the world, but it's probably difficult to find the right one. That's roughly the overview. So I will. But the last chapter is actually only if there is demand for it. If there are other discussions, we can of course follow the demand. Looking at the main types of rechargeable batteries, this is of course the lead-acid batteries, known to all of us from the cars. But lead-acid batteries, at least for those who receive e-waste in countries with unstable electricity supply, you know that you also get uninterruptible power supplies, probably in large quantities. And they normally all have at least one lead-acid battery inside. And we also find them, for example, in backup devices of hospitals, server rooms, mobile phone networks, so stationary equipment for power storage. And increasingly in countries where rural areas are not yet connected to electricity grids, there is a new trend for off-grid electrification via solar panels. So this is an additional driver where many countries now see a boom in lead-acid battery market penetration. Lithium-ion batteries, we have them, of course, in our mobile phones. We have them in our notebooks, but also in a number of other devices, camera, toothbrushes, electric bicycles, and starting roughly 1 or 2 years ago, also in stationary power storage, because the prices for battery cells dropped over the last years. So at a certain point, it becomes attractive for other applications as well. So nowadays, we can't say this is a solar power installation necessarily lead-acid battery. So the picture is getting a bit more complicated. And of course, electric vehicles will also use lithium-ion batteries. We also have nickel metal hydride batteries. They have been more prominent in the past. Now we increasingly find for those applications lithium-ion batteries because of the lower price. The drop in price for the lithium-ion batteries is playing an important role. Very often in power tools you find nickel metal hydride batteries. The good sign for recyclers, or the good news for end-of-life management, you can treat nickel metal hydride batteries as being lithium-ion batteries. So it does not overcomplicate the situation. So these are the main battery types recyclers are challenged with when it comes to appliances and rechargeable batteries. Lead-acid batteries. Looking at the battery, it's basically the box-type battery we all know from the cars. It might look a bit different. Usually very heavy because 65% of the weight is made of lead or lead alloys. And the setup is actually quite simple. When you would open it, which I think you should actually not do, you will find these plates, the electrodes, lead dioxide and pure lead floating in a diluted sulfuric acid solution. It's actually, from the whole construction, not very complex, and also leads to a situation which is quite hazardous because we have a heavy metal in it, 65% lead, and we have a strong acid in it. So it's, from the whole toxicity potential, probably for e-waste recycler, one of those fractions you should be concerned about most. If you don't treat it properly, you have a problem. At the same time, it's quite simple from the setup and also quite relevant for recycling. A lot of recyclers want them because of the lead. If you touch lead acid batteries in larger quantities, so more than one when you repair your car, you should make sure that all your workers and yourself should be equipped a bit like this, wearing overall gloves, safety boots, dust mask and goggles, even if you don't recycle them, even if you just serve as a hub for these batteries. Of course, avoid damages to the batteries, so don't put a nail in your pellets where you stack the batteries on. This is a common sight in many countries that battery hubs and collectors open the batteries to drain the acid. This is because a lot of off-takers and scrap traders, they want dry batteries. They don't have any use for the battery for the acid, and actually they want to reduce the weight and the whole hassle of dealing with wet batteries. This is something you should never do. This is of course quite dangerous for the workers. At the same time, you see that the liquid coming out is not only pure acid, it's black, and this says that you're also pouring out lead elements, particles into the environment, which is highly toxic to the local environment, and it's extremely difficult to get rid of this pollution afterwards. So if you engage in this, try to collect all batteries with acid wet, and this will help to avoid pollution in other parts of your country. So this is a very important aspect you should focus on, and never do this kind of practice. What to do in terms of handling when you are a recycler? Cap the positive pole to avoid shortcuts and overheating. Use a simple isolation tape or plastic caps, so very practical, simple measure. If you have holes in the batteries, try to close them with some material, and damaged batteries, even if they are already drained, should be additionally packed into a strong plastic bag or a bucket, because otherwise lead particles, it's not only solid lead, old batteries have lead dust in it, will inevitably emit if you don't do so. Storage, undercover, on sealed floor, upright and packed. It can look like this on a pallet. Don't stack higher than 3 or 4 stories. They are very heavy, so otherwise you will damage the lower levels of the batteries. As a layer in between, put cardboard in case you have a leakage of acid. It will absorb the acid. Other options are boxes, like this, covered of course, and these boxes should also be stored not in the outside and on sealed ground. In case you engage in this, we produced a couple of years back a poster on packaging of lead acid batteries for bulk transports. It can be downloaded from this link, and I think we'll provide this presentation afterwards to you anyway. It's available in a couple of languages, and if you want to print out this for your workers to be displayed in the workspace, we can send you a high resolution version upon request. Just drop me an email. For the recycling, 2 main factors to consider. Lead is valuable, so the London Metal Exchange price is $2,000 per ton. We have around 65% lead content in a battery, so this pays off. Indicatively, we have at the moment a price for waste lead acid batteries ranging around $600 per ton, very often higher in other countries. So in any case, you can expect some revenues when selling lead acid batteries. Lead acid batteries are technically easy to recycle, but it is not easy to do this in an environmentally sound manner, and this is an important issue. These are some impressions how it is done in developing countries, emerging economies, very commonly. And you see, out of these 6 options, 5 of them you should not do or not team up with recyclers. Option 1 is refurbishing. So people open the batteries, these are mostly small workshops, take out the damaged grids and replace them, fill it up with acid again and solder it to get a new battery. This is very often quite polluting for the immediate surroundings and very often conducted in populated areas. Don't team up with them. Recharging is okay, refilling acid is okay, but more operations on old batteries you should not do or promote. B is a company that focuses only on battery breaking. So they accept batteries, they break them, take out the lead, separate the lead from the plastics, and sell the lead and the plastics to recycling markets. It's very often done manually only, and manual battery break-in is something that should be discouraged. It's almost impossible to do manual battery breaking without endangering your workers. C, obviously, this is open lead smelting. I think that this causes high emissions. I don't have to say much about it. D is actually the same, a bit bigger, a homemade furnace, something you can't really control in terms of emissions. This will inevitably poison the whole neighborhood, so don't follow D. E is a bit larger scale. This is an industrial plant, an industry scale smelter, but also here you see smoke coming out of the furnace, you see debris around. We've seen a lot of substandard industrial smelters, and in these smelters, workers have a very limited life expectancy. So be careful whom to choose to team up for battery recycling. A modern battery recycling facility, at least the furnace, should look like in F. This is a modern rotary furnace where also the entry gate, where you charge the furnace, where you tap the lead from, is covered with a fume hood so that all the emissions that come out are ventilated to an emission treatment system. And also the other off gases of the furnace are ventilated to emission treatment system. So these are aspects you should care about. Don't give them to recyclers, even if they pay good prices, who do not follow ambitious standards. Just to give you some figures, responsible lead-acid battery recycling requires investments ranging at least between 4 and 6 million US dollars. So when you consider venturing this business, be aware that this is capital intensive. And this means that you will still set up a small scale plant, relatively of course, which will need roughly 24,000 tons of waste lead acid batteries per year. So normally these are highly specialized enterprises. There was a study a couple of years ago by the Blacksmith Institute, now called Pure Earth and Green Cross, and they're looking at pollution worldwide, and they actually concluded that from industrial pollution, unsound lead acid battery recycling is currently the most polluting industry in the world. I'm not sure if it's true, but what I know it's definitely a very polluting industry if you don't do it right. So be careful about the decisions in this field. These are some consequences for workers and neighboring communities. We have done a study on what has been found out in Africa a couple of years ago, and actually we only came across 3 scientific studies looking at health impacts on people, and all actually basically find out that workers in neighboring communities suffer from severe lead poisoning around these facilities, and basically show blood lead levels by far exceeding everything that is somehow allowed or recommended. So basically for e-waste recyclers, you might all receive mixed e-waste. Seek cooperation with a specialized lead acid battery recycling company. If you do it yourself, be aware you need quite some investments ranging into several millions US dollar. How to identify a responsible lead acid battery recycler. There are plenty out there, and almost certainly you find some in your countries. But first of all, it's important to recognize that you should not expect highest prices. The higher the offer you get, the higher the probability that the recycler you're dealing with does not apply best practices, because protection of the workers and the environment is a costly issue. So responsible recyclers reinvest some of their profits into sound processes. There is one list you might check, and this is the membership list of the International Lead Association. This is a link for it. Members of the ILA, when they apply for membership, all have to go through a quite extensive auditing process. So all their facilities are audited to avoid that dirty recyclers are taken up in the group of these world leaders in lead recycling. So this can give you some level of security. If there is no ILA member in your country, You need to check country-specific data, make field visits to potential recycling partner, but also there, possibly with the support of experts. If requested, I would have some ideas for a quick check you in the last chapter if needed. In case you don't find a suitable option in your country, consider stockpiling of batteries and probably exporting them to a recycler you can be sure he's doing it properly. Even in this model, you can expect to earn some money from batteries. Shipment costs should be compensated by the revenues. So, in case there are no immediate questions, I can follow up and just can go over to lithium-ion batteries and nickel metal hydride batteries. Otherwise, I can also offer to make a short break here and give you the floor to ask questions and voice your remarks.
So if anybody has any direct questions on handling of these lead-acid batteries, you can raise your hand or post a question in the chat, or just start to speak if you have questions regarding this treatment.
So then I suggest, if there is no immediate request, that I continue with lithium-ion and nickel metal hydride batteries, right?
Yes.
Okay. So lithium-ion batteries always consist of cells. They're often cylindrical in nature. And bottom left, you see this is a battery pack open from a notebook. So in many of these battery packs, you will find these cells. But of course, they can also be flat. Flat, you know them from your tablets, from your mobile phones. This is how they look like. You can also see from the nameplate the type of batteries and of course the type of use. For mobile electronic devices, you can almost be sure that the battery is lithium ion or nickel metal hydride. You see it here in the nameplate. And you also see that also this type of batteries is not really healthy when you throw it into the environment. The toxicity potential is lower than lead-acid batteries, definitely, but they're not free from hazardous substances. And the difficulty is even we can't really say what kind of hazardous substances is in a battery because the exact chemical setup is different in each type of battery and from each producer. We have seen lists of materials being embedded there, and it's such a long list of possible substances. You always have to assume you have a certain percentage of substances that are classified somehow as being hazardous. You have another very big headache with lithium-ion batteries, and this is the fact that once some of the cells still carry some remaining charge, a rule of thumb is more than 30% remaining charge, they can cause fires and explosions. This is the so-called thermal runaway, and that can occur after overcharging of a battery, a deep discharging, high temperatures, and physical stress. And a thermal runaway can happen any time after these events. You never know it. It can happen immediately, but also days or weeks after such a damage. Additionally, shortcuts when the poles are bridged can also create heat and lead to fires. And this is a quite serious concern because of the high energy densities. Waste lithium-ion batteries are known to be a significant fire risk in recycling enterprises all around the world. And the risk is even higher when batteries are stored densely, so that one burning cell can ignite neighboring cells, such as in this battery pack to the left, or in a pile of batteries as seen to the right. And also, of course, if the batteries are stored next to other material that might burn. And it in fact happens. This is just one example out of many actually. Last year in New York, and there are many similar cases where it's either sure that lithium-ion batteries caused recycling factory fires, or that they are suspected to do so. Just go on YouTube, you'll find numerous small clips and videos on burning lithium-ion batteries and burning recycling companies. So this is basically a subject that should be given priority. Fire risk mitigation strategy, absolutely necessary. Avoid all damages to batteries. Of course, you never know what the user has done to the battery, but you should not cause any additional damage to the cells. This also means you should not advise to dismantle battery packs. So these are the battery packs of notebooks. Don't open them, leave them as they are. Also there, cap the poles of the batteries. Use insulation tapes to avoid shortcuts. The storage area must be sheltered from heat, moisture and rain. And the storage area should be well separated from other areas of your facility. So make sure when a fire happens, it does not burn down everything. You have to assume that some of your batteries sooner or later catch fire. Additional fire risk mitigation measures are usually applied and should be applied, and usually a combination of the following measures are applied. One option is a manual discharging of all batteries. You have to avoid electrical shocks, of course, and this is, of course, labor intensive. A prolonged storage, several weeks, to make sure that a certain level of self-discharging takes effect prior to transport, so that most of your cells are in fact discharged. Storage in buckets and drums that are placed in some distance from each other, so that a fire in one bucket cannot ignite batteries in other buckets. And of course, not next to a pile of paper or plastic. Storage and transport of lithium-ion batteries embedded in sand, in buckets or drums, and in case of a thermal runaway, the developed heat is absorbed by the surrounding sand and produces a glass-like enclosure around the battery. This is the common way today of transporting lithium-ion batteries. And a permanent monitoring of temperatures in storage drums. In case there is an increasing temperature, you can take firefighting measures immediately. So consider these as options to be taken in recycling enterprises. This is how it can be done for shipment. These are mobile phone batteries, where you always have one layer of batteries and then one layer of sand. Again, one layer of battery and one layer of sand. And then close the drum. The drum should not be sealed off against pressure. If there is a fire, pressure should be able to go out of the drum. The design of the drum is not ideal. Ideally, it's plastic, because the metal can cause a short circuit of batteries. So if you do this, make sure the poles are kept. You also have to note that batteries are quite new in the waste stream, lithium-ion batteries. We have them for more than a decade, for 2 decades, but as a mass fraction, it's still quite new. So rules and recommendations for packaging and transport change quite often. And this, of course, has to do with events of burning factories, of burning waste trucks. So these regulations change very often. So basically, one recommendation would be, when you found someone to take off your batteries, ask them for guidance before teaming up and say, look, what do I have to do when I supply you? Give me the latest information, and also the information valid in all the countries the shipment goes through. There are some international packaging and labeling requirements, which is basically a minimum standard. The minimum standard can, of course, be higher in certain countries, and also this can change over time. First of all, use UN-proof containers. Packaging group 2, substances presenting medium danger. This can be such drums, but make sure that they fulfill the requirements of this packaging group. Labeling with class of danger goods 9. So this is actually a little sticker that should be visible from the outside of the load. And also the UN code 3090, which is for lithium-ion batteries for recycling. So you can either only stick UN 3090, even better, you use a sticker where lithium batteries for recycling is printed onto it additionally. Recycling of lithium-ion batteries is technically challenging and currently only done by very few enterprises. This is the list who are operating on the market at the moment, and unfortunately, the number is very limited. It's only in Belgium, USA, Canada, and Germany. So the market is changing quickly. At the moment, you only have for recycling an option to contact one of them or several of them and ask them for help and whether they would accept your batteries. I think they will happily do so and give you some guidance. To facilitate collection, some of the above listed companies developed support services such as drop-off points in some world regions and also pickup services, either by themselves or by their strategic partners. So go onto their website and seek for advice how to ship the batteries to them. Of course, they will charge for it. They won't do this for free, but on the other side, you might get rid of some logistical headache. Important, the recycling market for lithium-ion batteries is developing very rapidly at the moment. So the list above might not be valid anymore soon. New players will emerge on the market and diversifying the above list. So if you have large quantities of lithium-ion batteries, make sure you get on some battery-specific newsletter or magazines. Battery World, for example, this is a free magazine on the internet where opening of a new plant is always announced. When you recycle or get lithium ion and nickel metal hydride batteries, always be aware of the economic implications. It's not necessarily a profit for you. Lithium ion batteries, the recycling focuses basically on some very few materials. It's cobalt and primarily the cobalt that pays off. It's a bit nickel, copper, and lithium. I put it in brackets because it's not a primary target. It's a byproduct of the recycling process. The problem is for recyclers that primary lithium is actually quite cheap. It's being considered as a scarce commodity, but primary production is still extremely cheap. Secondary production is not cheaper, so it's always a byproduct. So cobalt is by far the main value carrier of waste lithium-ion batteries. And this is a detail I left out intentionally not to make it over complex. We have at the moment 5 to 6 main type of lithium-ion battery chemistries on the market. LNMC, LCO, LNCA, LMO, LFP, LTO. The chemistry is written there and their characteristics as well. The upper three, they contain cobalt and they have a very high energy density. And they are used in mobile electronic devices because they have such high energy densities. So the customer demand is to have a very slim mobile phone and a very strong battery. So this is the field where these batteries are used for. And they contain cobalt and therefore they usually have a positive net value. The figure is indicative. It's between 250 to 3,200 euros per ton, and it's very indicative. Different types have different cobalt contents, and over time producers, because cobalt is so expensive, try to reduce the cobalt content of the batteries. So newer batteries normally also contain less cobalt. So you can never really tell what you have in terms of value when you receive lithium-ion batteries. And these other battery types, they don't contain cobalt, but they are cheaper. The energy density is still high, but not that high as the other types, and they're a bit cheaper. So if you go for stationary equipment, backup systems, solar panels where the energy from the day needs to be stored for the night, and you use lithium batteries, you normally go for the cheaper types, LMO, LFP. And these are unluckily the batteries where sound recycling has a net cost. and actually are quite high net costs. So the material recovery is quite low and does not compensate the cost. An indicative value is 3,500 euro per tons, but also here it's quite indicative. Nickel metal hydride batteries. They contain significant amounts of rare earth elements, and some recyclers, at least I know this from Umicore, I'm not sure Umicore might be in the call today, they can recover these rare earth elements in the same recycling process as for lithium-ion batteries. And because the rare earth elements are quite attractive on the market, these recyclers usually pay a positive price for nickel metal hydride batteries. So they can be shipped together with lithium-ion batteries, so there's no separation from lithium-ion batteries or sorting needed, but make sure you again verify this information before you enter an agreement with a recycler. It might be possible that other recyclers, others from Umicore, follow another strategy. But as a rule of thumb, you can say there are companies on the market that accept mixtures, which makes life easier for you. So indicative prices, the prices I've shown in the slide before, for lithium-ion batteries need to be treated with care, because the costs for storage and shipment are quite significant and may change over time, depending on new and changing regulation. There are actually situations at the moment that some recyclers can't ship their waste batteries because they don't find a shipping agency to transport them. They've heard about these fires of lithium-ion batteries, and to be on the same side, they rejected all shipments. And this might be a problem. Therefore, it's again advised to contact the off-taker and follow the advice of these companies. Again, the cobalt content varies also strongly between different lithium-ion battery types, and the cobalt prices change over time. So this is just the cobalt price over the last year. You see the peaks and you see the lows, and you have so many factors in the pricing of lithium-ion batteries that you should be careful. When there is someone saying, I have a couple of tons of lithium-ion batteries, you should consider charging them for sound end-of-life management. So this is a short summary. There are three common types of rechargeable batteries: lead-acid batteries, lithium-ion batteries, and nickel metal hydride batteries. Lithium-ion batteries and nickel metal hydride batteries can be managed together. The main end-of-life characteristics of lead-acid batteries: very high toxicity potential, a positive net value, good recyclability, but sound recycling difficult and costly, high investment costs. So unsound lead-acid battery recycling is one of the world's worst polluting industries. The main end-of-life characteristics of lithium-ion batteries: it's a medium toxicity potential, but still it's hazardous waste. Significant fire risks during handling, storage, and shipment. The net value depends on subtypes and various other factors. So the net value is sometimes negative. And recycling is currently only done by some few companies in Belgium, USA, Germany, and Canada. And the recycling environment for lithium-ion batteries is developing, and recyclers should observe potential new recyclers in the market, changing requirements for storage and shipments, and potential new logistical support options, for example, by service providers. And of course, also changing market prices, driven, for example, by changes in the global cobalt prices. So that's the quick run through the two battery types. I would have another chapter on how to identify and sound lead-acid battery recyclers. But before I bore you all, it's probably time to hand over to you. Okay, this is a quick check. A quick check does not replace a full assessment. But for you who are out there contacting downstream markets, it's probably an option to get a first feeling. And sometimes it could also help you to pull out immediately. So I try to illustrate this with pictures. When you enter such a facility that might be your recycling partner, and you see this in the battery reception storage area to the left, you can actually turn around and go out again. The batteries are stored on bare soil. You have acid ponds around. They're stored in a chaotic manner, not upright, not sheltered. This is a violation which is a no-go at all. It should never look like this in your premises, of course, and never in the premises of partners you're working with. They should be undercover, upright, packed on paved floor. Right? In container, you could also use boxes. Um, these are the two extremes we have. If you're on the left side, I would warn you not to pick this as a partner. The next step in the process is battery braking. Also, again here, if it's done manually, as to the left, this is not an option. There are means of automated battery braking where people are removed from the acid mist, from the lead particles that inevitably emit during the battery braking process. So it should be an automatic process, and it should be a process where lithium-ion batteries are well sorted out. I spoke about fire risks, and we increasingly have box-type lithium-ion batteries that look like car batteries. Imagine someone as to the left opens a car battery with lithium-ion cells inside with a matchet. He risks an explosion. Acid management. No acid drainage like this. It sometimes happens in the supply chain. It also happens very often in the facilities. To the right, this was a picture taken into a formerly registered lead smelter. Acid management, to the left, this is not the best way, but it's acceptable. This is that acid is giving it a pond for controlled evaporation. It's better to recycle the acid, and you can use them actually to produce gypsum or to manufacture new batteries. So basically, you can make a saleable product out of it. So the way the company managed the acid should also be in the focus of your quick assessment. The next one is the furnace. How is the smelting done? To the left, you see a very outdated blast furnace where the smoke is coming out. You should never see any smoke coming out of a furnace. It should be all ventilated to an off-gas treatment. In no stage of the process, any smoke emissions can be tolerated. It's just too toxic what is in this furnace. A modern furnace is always a rotary furnace, so it's one of these drums you see to the right, and it should always be equipped with a fume hood, and the fume hood should develop enough suction to capture all emissions from the holes of the drum. This is 7 meters per second, so this feels like a storm when it is on full power, the off-gas treatment system. When it does not deliver suction effectively like a storm, something is not functioning. The off-gas treatment. To the left you see the rotary furnace, and the off-gas is passing through a chimney where the velocity and the temperature is reduced. And then you see in the gray boxes, this is first a cyclone where the heavy particles fall out, then into a backhouse filter where the fine particles are filtered out, and only then it's passed through a chimney. And very often there is still a scrubber step in between before it is released through the chimney. And this is how it should look like. This is always on the outside of the facility, so in the back before the plant, just in front of the blue wall, you see the cooling towers. Then further in the front, the box-like structure, this is the backhouse filter, and then you see the wet scrubber before it's released to a stack. So each lead-acid battery recycling facility should have a functioning system like this. And if you look at the box-type structures, there are outlets at the bottom. You should always look at these outlets. If the outlets look like this, the smelter is a problem. You basically filter out the most hazardous type of material from the off-gas stream, and then they release it again at the bottom. I've seen it so many times, and it's strange because then you call worker to shovel it into buckets where you can already place buckets behind it before this, so that nobody even gets in touch with them. Um, so this is a management aspect we very often witness, which is completely crazy. Every smelter is producing slags, and slags is a major management problem for most lead acid battery recycling facilities. The slag, when they come out of the furnace, they look black and they are hard. After storage for a couple of days, they turn red and soft. They're a bit like reddish soil. And this is the reason why a lot of smelters use this color and texture just to dump them somewhere. It's extremely different to detect whether this is soil or a slag. So every responsible smelter needs to provide a sound solution for the slags. And there are good measures. When you tune your process to reduce the lead content in the slag, you can use it for tile or brick manufacturing. You make a commodity out of it, which is acceptable for several uses, outdoor uses, for example, or uses in places with non-permanent residents. So a slag management is a very important aspect of responsible lead smelters. Then, of course, when you go in there and you see a health and safety policy signs like to the left, it's a heavy industry. You need proper signs. If you don't have proper signs, you can also assume there is no proper health and safety training, and health and safety does not play any major role. But it's a heavy industry. Health and safety should be first. Also, the general working environment. These are two extremes. The left one, where you can already see dust. Dust is a major management issue, a major contamination path in lead smelters. When you see dust on the floor like this, it's unsound. When the lead bars are stored like this, where they can topple over, every of these piles weighs 1 or 2 tons. The leg of a worker is off if it's under one of these bars. To the right, you see the best case, where the floor is constantly kept damp, so the dust particles are captured in the moisture, and the water is then captured and filtered, and the particles are refed into the furnace and recycled. So this is a major dust control measure. Personal protective equipment to the left. Nobody in a lead smelter should work like the person to the left. He's working at a furnace, and at a furnace, the workers should be equipped and look like astronauts. As here in the middle, who is actually working on a refining kettle, not at a, but still at this position, extremely stringent measures for personal protective equipment apply. Dust masks are a means to protect workers in less exposure places of a plant, but what we have seen here was actually a woman that was given a mask the first time in her life because she was wearing the mask the wrong way around. So the mask needs to fit properly, really filtering all the air that is inhaled. Change rooms and shower. A major problem for societies is the so-called take-home lead. That people work in their private clothes or in working clothes and are asked to wash them at home. Leaving a facility with dirty clothes and not showered leads to the fact that the families of the workers are also exposed to lead. So showers are mandatory, and there should of course be nut showers and separated male-female. And there is a very easy setup of change rooms and showers as illustrated here. It should be something like a gate where you can only enter facility through a change room where you have to take off your private clothes. You are equipped with washed, fresh working clothes, and then you can enter the facility. And when you walk out, you are not allowed to walk out without passing through a shower. So you take off your dirty clothes, give them to the laundry, walk into a shower. After the shower, only then you can access your private clothes. So build a system that every people entering the facility or leaving the facility is going through such a change room shower system. Canteens, of course, intake of lead via food and drinks is as a major thing. They should be very clean canteens and should be equipped with air conditioning and never, of course, with working clothes. And the air conditioning, it's not because it's cool, but because you create an overpressure in relation to the facility. So when a door is opened, the airstream is going out and not in, so that no lead particles are blown into the eating area in the canteen. So this is the quick check. And once you came across a facility fulfilling all these good practices, please give me a notice. We are searching urgently for such facilities all around the world. We know some, it's not impossible. It's not rocket science, as you have seen. And I would please you to be careful when choosing a downstream recycling option for lead acid battery recycling. We just heard about a recent case in Nigeria where a plant actually was set up next to a primary school, and blood lead tests shown that none of the children had no lead poisoning. So basically, it regularly leads to mass poisoning of people. So this was the quick check. I hope it was helpful.